Factors affecting solubility. Some of the factors that affect how some solute will dissolve in a solvent are influenced by several factors. Structural effects, such as polarity, will affect how one thing dissolves in another. Remember, like dissolves like. Pressure effects, which we would know as Henry's law. This is how pressure relates to solubility. For gases, this is especially important because as pressure increases, solubility of gases in liquids increases. Temperature effects. These affect aqueous solutions. So in general, as temperature increases, so does solubility. Here's an example of a gaseous solute. You can see the solution in letter A, and you can see that the vapor pressure above the surface of the liquid and the certain volume above the liquid and its solubility. Notice as pressure increases, you can see what's happening from B to C. The pressure is increasing because the plunger is being pushed down and there's less area or volume above the surface of the liquid. Notice the number of arrows going down into the solution increases, and there's more solute particles dissolved in the solvent, and therefore as pressure increases, so does solubility for gases. Temperature effects for aqueous solutions. Although the solubility of most solids in water increase with temperature, there are some substances that decrease with increasing temperature. Predicting this dependence is often very difficult. Solubility of a gas in solvent typically decreases with increasing temperature, and that's why we store our carbonated beverages in the refrigerator to decrease the temperature so that solubility increases. Here is a chart showing the solubilities of several solids as a function of temperature. You notice most of them increase. The blue line ones, like sugar and potassium nitrate, those increase with increasing temperature. But a couple, like sodium sulfate and cesium sulfate, these tend to decrease with increasing temperature. However, if we look at the solubilities of gas in water, in general, they tend to decrease with increasing temperature. So methane, oxygen, carbon monoxide, etc. As temperature increases, they become less soluble because they're less dense and they come out of solution. And vapor pressure of solutions. Remember, vapor pressure is the pressure pushing up on the surface of the liquid as it becomes a gas. Non-volatile solute lowers the vapor pressure of a solvent. This will become important in the next section when we talk about boiling point elevation and freezing point depression. Raoult's law, P solution equals mole fraction of the solvent times P0 of the solvent. You can see the meanings here. The observed vapor pressure of the solution, mole fraction of the solvent, and this is extremely important because solvent is the key word. It is not the solute. In the previous section we talked about mole fraction being moles of solute over moles of solution. Here we need the mole fraction of the solvent. It's the solvent that's important. And then the vapor pressure of the pure solvent, or P0 solve, is how we can calculate the vapor pressure of the solution.